Hello everyone, welcome to General Chemistry 1. Today our main goal is to calculate empirical formula and ultimately the molecular formulas from percent compositions. Okay, here's a good example. Determine the molecular formula of a compound that is 49.48% carbon, 5.19% hydrogens, 28.85% nitrogens, and 16.48% oxygens. The molecular weight of the compound is 194.19 grams per mole. Now, if you consider 100 grams of sample, notice that we don't have any number to work with. It's all percentage. Okay, and the key is we have to have some mass to work with, and we need moles, because a formula is based on the lowest whole number ratio, right? So we have to have more to work with. Now, if we consider 100 gram, then percentage is the same as gram, because 100 gram, 100%, right? So each gram is a percent. So if assume we have 100 gram, therefore 49.48% of carbon is 49.48 gram of carbon. And similarly, you have 5.19 gram of hydrogen. They come from here. You notice 5.19%. 5.19 gram, 28.85 gram of nitrogens, because percent is gram, and oxygen. Now you look up in the periodic table and you look up the atomic weight for carbon is 12.01, and you do the setup, 1 moles of carbon over 12.01, you cancel out the gram, you got 4.12 mole of carbon. You do the same for hydrogens and oxygens. Look up the hydrogen atomic weight, look up atomic weight of nitrogens and oxygens. So you get all this, 5.14 moles of hydrogens, 2.06 moles of nitrogen, and 1.03 moles of oxygens. Now, then you set it up. So you write everything out. Carbon is 4.12, hydrogen is 5.14, nitrogen is 2.06, and oxygen is 1.03. Now, how do you get the whole number ratio? And it has to be the lowest whole number ratio. That's the definitions of empirical formulas. And so the algebra trick will be you divide it by the smallest. That's how you start out with. You pick the smallest, which is 1.03. Everything. If you divide every single one by the same number, nothing changed. The ratio stay the same. Lucky, when we do that, it'll come out whole numbers. 4, around 4, you round it off, okay? Around 5, around 2 for nitrogens, and obviously 1 for the oxygens, okay? So that's C4H5N2 oxygen O. This is the empirical formula. This is the lowest whole number ratio among the atoms, or among the elements. Okay, now you turn around and look up the atomic weight for each of them. That's 4 carbon, so 4 times 12.01, 5 hydrogen, 5.01, and 2 nitrogens, 14.02, and finally that's an oxygen. You add those up. These are called empirical mass, okay, which is 97.11 gram per mole. Notice that we got 194.19 gram per mole. That's molecular weight. Then you ask yourself, what's the ratio? What's the multiplier, actually? You divide that and you got 2. So the empirical formula, the molecular formula, is simply double of the empirical formula. It's the multiple of empirical formula. In this case, it's double because the molar mass is double. 194.19 is double of 97.11. So you multiply it by 2. That's what double means. And when you multiply it by 2, you got CaH10N4O2. That's the molecular formula. And it's okay. They don't have the lowest whole number ratio, but that's okay because it's a molecular formula. Lowest whole number ratio is only for empirical formula. In organic chemistry, this happens all the time, you know. But in general chemistry, the empirical formula is also the molecular formula. For example, sodium chloride, magnesium sulfate, MgSO4. That's the empirical formula. It's also molecular formula. So it's the same in that case. All right. So that's how you figure out the molecular empirical formula and molecular formula based on the percent compositions. So remember, percent is the same as gram. convert it to mole, divided by the smallest to get the ratio. If we get lucky, we get all the same. If not, we just have to multiply it by a factor to make them whole numbers. Remember, they all have to be whole numbers. And then we use we calculate the molar mass, and then we use the known molar mass, given molar mass, to figure out the what we call the multipliers, okay, to get the molecular formula. All right, thank you guys, and see you in the next video. We'll do some other calculations.